Greetings everyone. Today we are going to present our project Hill Rescue, a human in loop coordinated robot system designed to improve disaster search and rescue operations. Our problem statement extends to a real world content which is disaster response reality. The earthquakes, floods, fire disasters are visibly there. We have a visibility issues when it comes to autonomous robots. There are a few uncertainties that they face, which is information overload or delay in decisions. When it comes to human rescuers, they face time constraint even though they are accurate enough. Existing systems lack real-time human-centered visualizations. So, how are we going to deal with it? Coordinated multi-autonomous robots are involved in it, track dynamic disaster observation, provide clear, actionable information, enable human decision making at right time. So, we are going to combine robot actions to the human decision programming and make it a more accurate and time constrained project. The goal is to build a mission control style interface for disaster response. Key idea is about the robots, humans, and the decisions taken at the right time. The main components of this project are the autonomous backend, visual front-end, human in the loop, and the triggers that we are gonna react to. So the workflow goes like this. The robot is a simulation point where it goes around and checks the locality that is given to the particular robot. Then the observations are given forwarded to the backend, and the confidence level of the observation is recorded. The live data API is generated, which is further forwarded to front-end mission dashboard. Here, our human and the loop action starts. The human will be able to observe, monitor, and react to the particular situation that is updated to the front end. The human decisions taken in that point because of the low confidence is again forwarded to the back end of the robot, which updates the robot behavior. The robot behavior again triggers the robot on the site and works accordingly. So, when it comes to backend, we have multi-robo simulation. We will be able to track all our robots. The region is again divided between the robots. This is to make sure we meet the time constraint because disaster response should be very quick so that we have a spontaneous decision to prevent a lot of issues. Then robot movement and sensing is also updated in the backend of the project. Confidence level scoring will be taking place. Trigger detection, daily activities are also mapped. As mentioned, the region is divided among the robots and the search will be updated among each robot and take the decision collectively. This reduces overlapping and converts a parallel exploration for it. Observation type. Whenever a robot tries to detect something, it doesn't only mark a location of the disaster, but also gives some inputs about that location. Suppose the location of the particular region that it is looking to, the description, if there is a person detected or is there any disaster detected over there, or the source of the disaster, something like that will be described through that particular input that we get from the robot. The confidence level of that observation is also calculated. The images of that observation is also sent to the front end of the particular project so that human will be able to react to the inputs. Then comes the confidence and trigger. When there is a trigger alert given in our front end, that means the confidence of the particular image is low. Suppose a robot is detecting fire in our locality, it sends the snap of that particular image, what it is looking at, and how confident it is about its detection. If the confidence level is low, the survivor is suspected. The human and the loop logic comes into the picture where human looks at the images and gives his own input saying that yes, there is an image, a person or a disaster or a fire happening in that particular region and confirm if that is a trigger point or no. Then comes the front end. In front end, we actually deal with the disaster map. disaster map, region boundaries, robot positions, exploration progressions, observation markers, and live alerts. We have map visualization, we have observation details. We also track the daily activity of this uh, daily activities of the operations that we dealt with through these robots. Suppose on 15th August, we have dealt with a fire accident where these are the observations, these are the survivors, and these are the robot actions that took place, and all the timelines are also recorded in our daily log so that the model will be learning simultaneously through its current activities through too. So the impact of this project is to give a faster rescue decisions, reduce response risk, better coordination, trustworthy API development. So I would conclude